JWST just destroyed our understanding of space. The 13-billion-year-old secret, Big Bang over. The cosmos has secrets. Hidden in the earliest light of the universe, something ancient stares back, challenging what we thought we knew. And it's not waiting for permission to rewrite the rules. The James Webb Space Telescope, humanity's most powerful eye on the cosmos, has pierced the veil of time. It has unveiled galaxies so ancient, they existed just 500 million years after the Big Bang. But here's the twist. These aren't primitive baby galaxies. They're vast, complex, and evolved, like discovering fully built cities in a newborn world. This revelation has rocked astronomy to its core. Scientists have identified 6 galaxies, each as massive as the Milky Way, formed when the universe was only 3% of its current age. These aren't cosmic toddlers. They're seasoned giants with ancient stars and refined structures. It's like stumbling upon a skyscraper in the Stone Age. According to the Big Bang theory, the early universe was a hot, chaotic soup of gas, gradually forming stars over billions of years. Yet these galaxies seem to leap ahead of the timeline, appearing fully formed in a cosmic blink. Could it be that our cosmic clock is wrong? Or is the universe's origin story far stranger than we imagined? The Lambda-CDM model, cosmology's reigning theory, predicts that early galaxies should be small and chaotic. But JWST's data is in direct conflict. These newly found galaxies are 10 to 100 times more massive than expected, featuring supermassive black holes and organized spiral structures that shouldn't exist so early. One daring theory now gaining momentum. Could these be relics from a universe before ours? Cyclic cosmology suggests that the cosmos goes through infinite cycles of birth and death. If that's true, these galaxies might be survivors from a previous aeon, ghosts from a time before time. Another possibility shifts the focus to dark matter, the invisible framework of the universe. Some scientists propose that dark matter behaved differently in the early cosmos. Theories like self-interacting dark matter suggest it may have accelerated galaxy growth. But even these ideas are straining the edges of known physics. Alternatively, maybe we've misunderstood the pace of the early universe. If cosmic expansion occurred faster than previously believed, galaxies could have formed in just millions of years. But this raises a problem. It clashes with the cosmic microwave background, the most trusted fingerprint of the Big Bang. JWST's infrared vision exposes the unseen. Take Glass, Z13. A galaxy 13.4 billion years old, flaunting tightly wound spiral arms, features that should take billions of years to form. Its very existence whispers of unknown physics, or perhaps a cosmic shortcut coded into the laws of creation. Some skeptics suggest these could be black holes cloaked in starlight. But JWST's spectral data reveals otherwise, clear signs of mature stars, and the presence of oxygen, carbon, and neon. These elements form only after generations of stars have lived and died. The evidence is undeniable. The implications? They're nothing short of staggering. If galaxies form this fast, it means the first stars ignited a mere 200 million years after the Big Bang. That timeline is so compressed, it leaves little room for the slow, gravitational choreography that traditional models predict. Even Einstein's sacred equations are under stress. Could gravity have behaved differently back then? Some fringe theories, like variable gravity, propose it was stronger in the early universe. But to accept that means rewriting the bedrock of modern physics. New observations from the universe's dawn, its first light, add to the mystery. JWST's deep field images reveal a foamy swirl of galaxies crowding the infant cosmos, as though someone hit the fast-forward button on creation. Enter the idea of dark stars, hypothetical early stars powered not by fusion, but by dark matter annihilation. These exotic entities would burn hotter and form faster, potentially seeding galaxies in record time. But so far, they remain speculative, figments of theoretical math. The data is so disruptive, Whispers are emerging in the halls of science. Could the Big Bang theory be incomplete? Long-dismissed ideas like the steady-state model are being dusted off. Yet, even the skeptics admit, evidence for the Big Bang remains overwhelming. Clues also lie in the galaxy's metallicity, the amount of heavy elements they contain. JWST detects more metals than expected, implying rampant supernova explosions. But those take time. This suggests stars weren't just forming. They were racing toward explosive deaths at an unprecedented pace. Cosmic inflation, the universe's exponential growth spurt after the Big Bang, might hold answers. If inflation lasted longer than we think, it could have stretched tiny density ripples into galaxy-sized seeds. But altering inflation theories risks unraveling other key predictions in cosmology. And the philosophical questions begin to stir. Could the universe recycle itself? Sir Roger Penrose's conformal cyclic cosmology envisions a cosmos where black holes from a dying universe seed the birth of the next. Incredibly, JWST's galaxies seem to fit within this cyclical framework. Meanwhile, simulations are in crisis. Supercomputers trying to replicate these early galaxies either fail or spit out absurd results, unless scientists use highly unrealistic input data. It's as if nature is mocking our understanding with a far more intricate script. There's a sense of déjà vu. In the 1920s, Edwin Hubble shattered the belief that the Milky Way was the entire universe. Now, JWST's discoveries may be doing the same, forcing us to shift the question from how do galaxies form to how could they form so fast? JWST's treasure trove is public. That means anyone, even amateur astronomers, can hunt anomalies. In fact, one citizen scientist recently flagged a galaxy cluster that appears older than the space around it, a cosmic paradox begging for answers. Skeptics caution that cosmic dust might be tricking us, reddening light to make galaxies appear older. But JWST's instruments are designed to detect and correct for dust interference. And yet, these galaxies stubbornly remain ancient. The cavalry is coming. New telescopes like the Nancy Grace Roman Telescope, 2027, will survey wider regions, while ESA's Athena X-ray Observatory will zoom in on early black holes. This mystery will demand every wavelength we can throw at it. Even if the Big Bang endures, its details are unraveling. Maybe dark matter isn't cold, but warm or fuzzy. Exotic candidates like axions or sterile neutrinos might change how galaxies grow. The physics is still fuzzy, but the questions are sharpening. Meanwhile, the public imagination runs wild. Social media users call these galaxies time travelers and cosmic ghosts. It may sound poetic, but it reflects a deeper truth. We're witnessing something that reshapes humanity's understanding of time and existence. Religion and science begin to overlap. Some see echoes of eternal cycles in Hindu cosmology. Others muse about multiverses. But scientists seek testable truth, and JWST is already turning its gaze toward primordial hydrogen clouds and quasar shadows to decode it. For now, one fact is unshakable. These galaxies exist. What do they mean? That's still up for debate. They're like a cosmic Rorschach test. Some see new physics, others a flaw in existing models. But one thing is clear, the era of certainty is over. And then comes the big question. If galaxies emerged so quickly, could life have done the same? Might ancient civilizations have sparked in these distant, early worlds? It's pure speculation, but thrilling. A reminder of how vast our ignorance still is. JWST's mission is still in its infancy. It's now preparing to look even deeper, toward galaxies just 200 million years after the Big Bang. Each new image has the potential to upend what we thought was settled science. Behind every pixel of JWST's images is a battle between what we know and what we might be missing. The telescope isn't just showing us galaxies, it's exposing the scaffolding of the universe, daring us to reimagine the cosmos from its foundations. As the debate rages, one truth pierces through. The universe isn't a passive backdrop. It's dynamic, unpredictable, and richer than even our boldest theories. JWST hasn't disproved the Big Bang, but it has cracked open the door to a far more wondrous cosmos, demanding that we rethink everything, including our place in it. We looked into the dark and found ancient light, so bright, it questions everything. The James Webb Space Telescope didn't just open a window into the past, it opened a mirror. And now, the universe is looking back,